Good morning, everyone, and welcome back again. I'm Miss Sandari, and this is Science Equals Fun. Today, we're going to talk about the erosion of ozone layer and the global warming. Shall we start? Let's go. Let's start by talking about the erosion of ozone layer. But before we talk about the erosion of ozone layer, shall we talk about the structure of ozone layer? Okay. When the ultraviolet rays fall on the oxygen molecule, it causes the breakdown of this oxygen molecule, or cause a breakdown of the double covalent bond. We know that between the oxygen molecule we can find two covalent bond, or we can say double covalent bond. The ultraviolet rays will cause a breakdown of this double covalent bond, and then we have two free oxygen atoms. After the breakdown of the double covalent bond, we have two free oxygen atoms. Each one of of these free oxygen atoms will combine with oxygen molecule, forming ozone molecule. So again, when ultraviolet rays fall on the oxygen molecule, it will cause a breakdown. It will cause the breakdown with double covalent bond, giving us two free oxygen atoms. Each one of them will combine with oxygen molecule. So one free oxygen atom will combine with one oxygen molecule, giving us ozone molecule. Shall we move to the next point? Let's move. Now let's talk about the location of ozone layer. Okay, the location of ozone layer. The ozone layer extends from 20 kilometer to 40 kilometer above the sea level. Where we can find it in which layer? We can find the ozone layer in stratosphere. So we can find ozone layer in the stratosphere, which is the second layer. Now the thickness of ozone layer. Previously, we've said that the pressure at sea level is called the normal atmospheric pressure, and it equals 1013.25 millibar. So the temperature, the pressure at sea level, let's consider this one is a sea level. So the pressure at sea level is known as normal atmospheric pressure. And the temperature we here, and we have a specific temperature here, and of course the temperature here at sea level is different from temperature here. Okay, the temperature and the pressure at sea level are known as STP, which stands for standard temperature and pressure. S stands for standard, T stands for temperature, and P stands for pressure. So STP stands for standard temperature and pressure. Okay, just imagine this with me. We know that the ozone layer exists in the stratosphere. Let's consider this here is the stratosphere, and here we can find the ozone layer. If we took this ozone layer down at sea level, mean at STP, as standard temperature and pressure, what will happen? We will notice that instead of the thickness of ozone layer, instead of being 20 kilometer, it will become 3 millimeter. So if we took the ozone layer and put it down near the sea level, we will notice that its thickness, it will not be equal, it will not equal 20 kilometer, it will be 3 millimeter, and this is a huge difference. Okay. So STP means standard temperature and pressure. Dobson is a scientist that said if we took the ozone layer from the stratosphere and put it down on the ground. Okay, Dobson assumed that the normal degree of ozone layer is 300 Dobson, depending on what? Where each 1 millimeter equal or is equivalent to 100 Dobson. So since we said that if we put the ozone layer at sea level, we notice that its thickness will become 3 millimeter. Depending on that, he assumed that the normal degree of ozone layer is 300 Dobson, where each 1 millimeter equal 100 Dobson. Okay, since 1 millimeter equal 100 Dobson, does this mean 3 millimeter equal how many Dobson? 300 Dobson. Okay, so when he asks you about the thickness of ozone layer, the answer is 20 kilometer. But when he asks you about the degree, normal degree of ozone layer, 300 Dobson. Such a difference between the degree and the thickness. The thickness is 20 kilometer. The degree, 300 Dobson. Okay. And the degree of ozone layer is measured by Dobson. Okay, now let's talk about the types of ultraviolet rays, or we can say simply UV rays. We have three types of ultraviolet rays: near, medium, and far. Okay, we will differentiate between, or we compare between three of them depending on the wavelengths and the range of penetration and its effect on living organisms. Let's start by the first one, the wavelength. We know that each wave and has a length. Okay, and the length of the wave, which is the wavelength, is measured by nanometer. Nanometer. So we can measure the our height depending or using which unit, using meter or centimeter. But we to measure the length of a wave, or to measure the wavelength, we use nanometer. Okay, let's start by the far one. The far ultraviolet rays, its wavelength equal or from 100 to 280 nanometer, while the medium, look at this one, 280, start from 280 to 350, and the near one starts from, can you see this number, 350, started from 350 to 400. Okay, this for the wavelengths. I think it's easy. Now let's move to the penetration. And this one is important, so please pay attention with me. Okay, the far one. Okay, the far one can't reach us. So the far one, the far ultraviolet rays don't penetrate the ozone layer by a percentage of 100%. So 100% of the far ultraviolet rays can't penetrate the ozone layer. As you can see, it stops here. It can't reach us, thank God. While the medium one, 95% of the medium ultraviolet rays can't penetrate the ozone layer, while 5% of the medium ultraviolet rays can reach us. And the last one, which is the near ultraviolet rays, 100% of ultraviolet rays can reach us. Of the near ultraviolet rays, to be specific, the near ultraviolet rays can reach us. So again, 100% of near ultraviolet rays can reach us. Only 5% of medium ultraviolet rays can reach us. Only 5%. While 95% of the ultraviolet rays can't reach us or can't penetrate the ozone layer, while 100% of the far ultraviolet rays can't penetrate the ozone layer. Okay, the next step, or the next thing we're going to use to compare between near, medium, and far is going to help us to more understand the penetration. Okay, we said that 100% of the near ultraviolet rays can reach us or can penetrate the ozone layer. And this why the near ultraviolet rays are useful for us. So thank God God have made the near ultraviolet rays useful for us, and 100% of the near ultraviolet rays can reach us or can penetrate the ozone layer, while the medium and far ultraviolet rays are harmful. And thank God that only 5% of the medium can reach us, and the rest of medium and near and far, and far ultraviolet rays can't reach us. So, for the last time, 100% of near ultraviolet rays can reach us, only 5% can reach us of a medium, 95 can't, and 100% of the far ultraviolet rays can't reach us. Okay, now let's move. Okay, shall we start? Okay, the next one, the ozone hole. What's meant by ozone hole? The ozone hole meaning means the thinning or losing pores. So this is, let's imagine that this is the layer of ozone layer. Thinning mean it become like this, thinning, or losing pores, or even losing pores of the ozone layer, losing parts of ozone layer. So it's the thinning or losing parts of ozone layer above the south and the south pole of the Earth. So it's meaning the thinning or losing parts of the ozone layer above any part of the ozone layer of the Earth, of the sea, the south pole, above the south pole of the Earth. Okay, now look at this image, represent the degree of ozone layer. Okay, the green one here over here, represent or refer to regions in which ozone layer is in its normal state, which equal 300 Dobson, while the violet color refer to regions in which erosion of ozone layer. So the violet, erosion of ozone layer. Green one, normal state of ozone layer. So where is the number and where is the erosion? The normal green, erosion violet, normal green, erosion violet, and here erosion, erosion, erosion here, erosion, 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 and the normal is the green one. Okay, as you can see, each year the ozone layer keep increasing, or the ozone hole keep increasing each year, and this is a huge problem, as you can see. So the green refer to the normal, and the violet refer to the original ozone layer. Okay, now let's talk a little about the pollutants of ozone layer. Okay, we have a lot of them. Okay, pollutant of ozone layer. Let's start by chlorofluorocarbon compound, CFCs. They are chemically known as ferrions, which are used in, or which is used in, as a cooling substance. We can find them in air conditioning or in refrigerators or fridge, as you can say them. Okay, and it can, so at first it is used as a cooling substance in air conditioning and in fridge. The second one, which is used as a propellant substance in aerosols, and a flattening substance in foam backing, and a solvent substance for cleaning electric circuit board. So it is used for four purposes: cool substances in fridges and air conditioning, propellant substance in aerosols, and flattening substance in foam backing, and a solvent substance for cleaning electric circuit boards. Okay, the next one. Pollutant of ozone layer is the second one. The first one was chlorofluorocarbon compounds. The second one, which is methyl bromide. Methyl bromide gas. It's used as in insecticides. We know that the farmers grow the plants so they can sell them and get money. When the insects eat these plants, they will not be able to get money. So they use insecticides to kill the insects. In this insecticide, we can find methyl bromide, which causes the ozone layer. The next one, which is halons. Halons are used in extinguishing fire. So halons are used in extinguishing fires. The next one, nitrogen oxide. Okay, the burning of fuel in ultrasound controlled airplanes causes the production of nitrogen oxide, which causes the ozone layer. The erosion, I'm sorry, the erosion of ozone layer. So we've talked about four main causes or pollutant of ozone layer: chlorofluorocarbon, CFCs, nitrogen oxide, methyl bromide, and halogens. Okay, I think this is enough for today. If you have any inquiries, comment below and tell me. And thank you for watching.